Hello, my name is Santiago Espinosa Dominguez, and I'm going to explain you the solution of the second argumentative examination. Well, the problem one tells us that we need to calculate the moments of inertia of a unit sphere with these equations with the respect to the three axes when this density is 1. Well, for the first problem, we need to use the triple integral and we use these limits. We use these limits because are the limits of the sphere, but notice that the one is the radius. I put one because the problem tells us that this is a unit sphere. So I first integrate with respect to theta, and when I integrate, I notice that the second integral will be so difficult. So I transform to polar system with these equations. So when I see an x squared plus y squared, I transfer to r, and when I see a y or x alone, I transform to r cosine or r sines. But in this case, we have a y alone, so I transfer to r sines. And then when we need to change the limits, so first we change the limits of the theta, and we know that a circle goes to 0 to 2 pi. So these are, and then the limits of r that goes to 0 to 1. And we need to multiply the r to the equation because we need to do it when we change to polar system. And the result is 2.0745. And with the other axis, I do the same thing with the change of the polar system multiplied by r, the same limits, and the result is 2.0714 in the y-axis, and in theta is 1.6755. The problem should tell us that we need to calculate the mass and the center of the mass of the cylinder. Notice that now it's a cylinder, is not a mass, is not a sphere. So they give us the equation, and in theta, they gave us the limits and the density equation change. So first we obtain the mass and we put these limits that are like the sphere, but the limits in theta change to 1 to 2 because they gave us that limits. So I did the same. So in this point, I transformed to polar system. I add the multiply by r, the limits to 0 to 2 pi, and the radius, and the result of the mass is 3.6652. And in the components of x, y, and theta, I do the triple integral of the respective equations, multiplying by x, y, and theta with his respect components. And when we obtain the result, we multiply by the mass that we obtain in this. So when we multiply, the component of x and y gave us 0 and theta 1.6. This is because the center of the mass is y and x are 0, and in theta is more elevated because the limits that they gave us.